Hey coding words. So basically in today's GFG POTD we have a problem. Search insert positions of k in a sorted array, and it is an easy to solve problem. And the problem statement is given as given a sorted array R, which is like zero based index of distinct integers and integers k. Find the index of k if it is present in the array R. If not, return the index where k should be inserted to maintain the sorted order. So here basically in the given problem, here we have a sorted array, and every elements inside the array are like distinct element. That means they have like unique frequencies, okay, and they are like arranged in the sorted form. So here our task is to return the index value. Like if the k value is like present inside the array, then we have to just simply return its index value. But if it is like not present, then we have to like insert those k values to the particular index. So we have to return those particular index value where we have to insert those k value. Like for example, if I'm talking about the example, so here in the example one, here the sorted array is like 1 3 5 and 6, and k is like 5. So we have to first of all check whether the k element is like present inside the array or not. So while checking this array, we actually getting 5 here, and its index value is like 2. So since 5 is found at index 2, so here we have to just simply return its index value, that means 2. Now if I'm talking about the second example here, so here again k is like equal to 2. So if I'm going to check about the k is like present inside the array or not, so 1 3 5 and 6, so here k is like not present. So now we are going to try to insert this. So where we have to insert it, so we know very well, we have to insert just after 1. So that means, so that it will become like 1 2 3 5 and 6, so that it will become like it will be like distinct and also sorted manner. So here we have to insert at index 1. So here we have to just simply turn our output as 1. That means on the index I we have to turn our k value. The element 2 is not present in the array, but in inserting it and at index 1 will maintain the sorted order. Now if I'm talking about the third case here, which is like 2 6 7 10 14, so, and here our k value is like 15 here, and 15 is like not present inside the array, so we have to insert it. So we know very well we have to insert it just after 14, okay, so that it will become like maintained in a sorted order, as well as every element is like unique here. So how we can solve it? So first of all we have to see about how we have to solve. The time complexity is like order of log n, and auxiliary space like order of 1, and it is like Ash in Microsoft company, and it is like completely based on searching and algorithms. Okay, so by watching this topic text we know very well that this concept is like completely based on like searching here. So we know very well there's like two types of searching, like we can say linear search and then binary search. Okay, so by using linear search, first of all we know very well we can simply turn our index value, right? Like first of all we have to like for int I is equal to 0, I is like less than array dot size, and then I plus plus I plus plus. Then after that here we have to check, we have to give the condition, like I'm saying that if my array of I is like present inside, we can say that if the k is like present inside those array, then we have to just simply return I. Okay, that means the index value. This particular code is like satisfying this first examples. Okay, it satisfies completely our first example. But if I'm talking about the second and third case, it is going to be like return wrong case, okay, wrong output. So now what we will do, the logic behind this problem to solve the given problem is like that. Here we have to insert, that's if I'm talking about the second case here, second example here. So here our k value is like equal to 2, so we have to insert it. So where we have to insert it, we have to insert just after 1. That means we have to just simply insert after 1. So here we have to just for comparing it, okay, like we know that our two values like greater than 1 but less than 3. So how we will do these things? Here we have to just simply check for second case. So on the behalf of double equal to, here we have to just simply give greater than equal to. So this will satisfying both the case. If it is like equal to 5, then also we have to return I, and if it is like not available also, then we have to just insert those values at the particular index also. Okay, so in that case also, let's say here I'm saying that 2, so like 2 is like not available, so in that case also we have to return at position I, that means 1 0 and 1, that means on these positions we have to insert it. Now this will satisfying for all those conditions, but in between elements. If I'm talking about the third case here, so like talking about 15, so if I'm going to like uh, explain about this code for just k is equal to 15. So let's say for array of I, that means talking about 2 is like greater than 15, yeah. 6 is greater than 15, yeah. 7 is greater than 15, yeah. Then also 10, 14, yeah. 14 is greater than 15, but after that what, we it is not going to be like traversable. So at the last we have to simply say that this we can easily able to make out the idea that this particular index or this particular value of k is like inserted at the last element if it's satisfying all the condition here. Okay, so here to simply return array dot size. Okay, let's try to compile and run. So yeah, that's all about this problem here. This is the only approach. So yeah, here compilation is completed. Let's try to submit it. So yeah, it's submitted. So yeah, that's all for today. Thanks for watching. Only for this problem, there's only two things we have to consider. That means if the element, we have to just simply follow this case here. If the element is like greater than or equal to k, we have to just simply put at it index value. If it is like satisfying all those conditions but it is like not available in between, then we have to just simply put at the last. So we have to just simply return array dot size. That's all about this problem. So yeah, that's all for today. Thanks for watching.